Question 24 has some A and B terms all kind of mixed together in a great big fraction, and we're supposed to try to figure out how this simplifies into one of these choices. So when I look at this, I would deal with this A at the end, but this right here is what we refer to as a complex fraction, which just means you have some smaller fractions within a bigger fraction. And generally speaking, the best way to deal with that is to find the least common denominator of the smaller fractions. So this one has a factor of a plus b, this one has a factor of 1, this one has a factor of 1, so the least common denominator is going to be a plus b. So you can multiply one of these by a plus b, as long as you're willing to multiply them all by a plus b. Now the purpose of this, the reason why people like this approach, is because then right here, timesing by a plus b and dividing by a plus b, those are inverse operations that are just going to cancel. So that makes all of that just b plus 1. Now over here, this is b times a plus b. I'm going to go ahead and distribute that. I can factor it out later if I change my mind. And up here I have 1 times a plus b, so this is going to be a plus b. So it may not look neater to you at this point, but you need to understand that it's no longer a complex fraction. First step had a fraction within a fraction, which is a bigger problem than this. At least I don't have the smaller fractions within the bigger fraction now. So it's no longer a complex fraction. And again, you achieve that by multiplying by the smallest thing you can to make the denominators go away. This problem, that was multiplying everything by a plus b. Okay, next, for the second half of this is to me like adding a fraction. A over 1 is a fraction, and then all of this is a fraction. Well, if you want to add or subtract fractions, you need to find a least common denominator between those. And so the least common denominator, 1's not going to have any effect on that, but we need a b squared, an ab, and a plus 1. So I need to fix each of these so that they have that denominator. Well, this right fraction has that as a denominator, so I don't want to make any changes to it. This denominator does not have that, so I would like to multiply its denominator by b squared plus ab plus 1, and to keep it equivalent, you have to multiply the numerator as well. You can see that if we wanted to, we could cancel these out, and it would go back to being a. So this is still equivalent to a, it's just a little fancier way to write it. And we want to write it this way because then these have a common denominator, and when you want to add fractions, just like if you added, I don't know, 1/2 plus 3/2, you add the numerators, put it over the common denominator, and reduce if you can. So that's what we're going to do. We're going to add the numerators. I guess I'm going to distribute this. Plus this numerator. Put it over the common denominator. I don't need to add the denominators, just like you don't add the denominators there. And let's see if there's anything that would combine here. So this, I distributed that, and something doesn't look right here. A plus, this is supposed to be E. It's supposed to be A plus B. This is coming from here. So it looks like I could combine those two at least. So I need the answer that has this as a denominator. If we look back at our choices, they have it written in a little different order, but it looks like choice C is on the right track. It has a b squared plus an ab plus 1. I also have a b squared plus an ab plus 1. And in the numerator, I have an a b squared. There's their a b squared. I have a squared b, which choice C has. And they also have a 2a plus a b. As soon as we combine these like terms, we also have a 2a plus a b. So that's how they're arriving to that answer. So it's really, I see this as kind of two big steps. Step 1, we dealt with this complex fraction. We wrote it so that it's no longer a complex fraction. And then step 2, we needed to add these fractions together. Find the least common denominator, change the left one so that they have a common denominator, and then when we pulled it all together, it was distributing and combining like terms. And in the end, choice C was the only one correct. Now you can see that they're all fairly different choices as well. So if you were pretty confident that you knew what the least common denominator was, I knew that way back up here, and only one choice had this as a as a denominator. So very likely I could have just stopped up there and gone with that choice without doing all the rest of this.